Welcome to Ask and Learn.
We're asked to construct a deterministic finite-state automaton that recognizes the set of all bit strings that contain exactly 3 zeros. So this is going to be a hard set to describe in terms of smaller sets. So I'm just going to say that the set S is going to be the set of all bit strings with exactly 3 zeros. So let's designate S0 to be a start state. And let's consider four other states. So we have the S0 represents that there were no zeros in the previous bits. So for example, if we're just starting out, we don't have any previous bits. And so it follows that there are no zeros in the previous bits because there are no previous bits. And S1 will represent that there is exactly 1 zero in the previous bits. S2 will represent that there were 2 zeros in the previous bits. S3 will represent that there are 3 zeros in the previous bits. And we see that this is going to be a final state. And we have that S4 represents that there were more than 3 zeros in the previous bits. So the only final state is S3. So let's think about the transitions here. We're going to move from S0 to S1 if we come across a 0. So suppose that the string contains a 0. And we're going to move from S0 to S1. Otherwise, we'll remain at S0. This is in the case when the string does not contain any zeros. And now, suppose that the remaining string contains another 0. And we're going to move from S1 to S2. And otherwise, if it doesn't contain a remaining 0, we'll remain at S1. And finally, let's suppose that the remaining string contains a third zero, and we're going to move from S2 to S3. And otherwise, if the remaining string does not contain a third zero, so the string only contains two zeros, we're going to remain at S2. And let's suppose that the remaining string contains a fourth zero. Then we're going to move from S3 to S4. Otherwise, if the string does not contain a fourth zero, then we're going to remain at S3 because the string will only contain three zeros. And finally, regardless of what the remaining string is, we're going to remain at S4 once we reach S4. There's no way to take away the